Let's review how to find the inverse of a function. Recall, we replace f of x with y, and then we replace y with x and x with y. So we would get x equals the square root of y plus 2 divided by 3. And then we would solve for y. So let's see, if I multiply both sides by 3, I would then square both sides, and I would solve for y. And then you really should change that to the symbol for the inverse function. That's how we found the inverse of our functions. Well, can we apply the same process to our exponential functions? Well, let's give it a go. So we have y equals 2 to the x. Then we replace x with y and y with x. Now somehow we have to isolate y. We really don't have a way to do that until now. The exponential function has an inverse called the logarithmic function. This is going to allow us to find the inverse of the exponential function. So let's go ahead and define our logarithmic function. For all x greater than 0, which means x has to be positive, and b has to be positive. And remember, exponents have a base, so that's our b, and our base is not equal to 1. Then b to the y equals x, which is what we have right here, is equivalent to y equals log base, in this instance 2, of x. The function f of x equals log base b of x is the logarithmic function with base b. So part of this lesson is learning how to graph the logarithmic function. Well, we're going to do it by graphing the inverse. So let's go back to our exponential function. Remember, the domain is all real numbers. The range is from 0 to infinity. But let's get the rest of this. Remember, we would plot things, let x be 0, and we would get 1. X be 1, we would get 2. 2 is 4. And then remember, when we went negative, we got 1/2 and 1/4 and so forth. And we got a graph like this. We also talked about having an asymptote at y equals to 0. So we have y equals to 0. We have no x-intercept, and our y-intercept is 0, 1. If we want to graph the inverse, remember, we change everything. So the domain becomes the range becomes the domain, the x-intercept becomes the y-intercept, and so forth. And even here, we would place y with x. So our domain is going to be 0 to infinity. Our range is all real numbers. And recall, we interchange x and y. So we would have 1, 0, 2, 1, 4, 2, 1/2 negative 1, 1/4 negative 2. And we would have the asymptote of x is equal to 0. Remember, that's a vertical line. X is equal to 0. So let's see, we have 1, 0, and that is our x-intercept. We have no y-intercept because of the asymptote. And let's see, 2, 1, 4, 2, and then if we go 1/2 negative 1, and so we would have that graph. And remember, it would be a mirror image if I graphed them on top of each other. It would look like that because we have that line of symmetry of y is equal to x. So this is what our basic log graph looks like. So remember, our domain is 0 to infinity, Our range is all real numbers. We start out with the x-intercept of 1, 0, and we have that asymptote, vertical asymptote. So let's just practice another one. What if we have base 4? Well, again, if you want to plot some points, when x is 0, y is going to be 1, 1, 4, 2, 4 squared is 16, a little bit tall, but we should know that the graph is very similar to the last one. It's just as the base changes, it might bend a little bit differently. So remember, our domain is all real numbers. Our range is 0 to infinity. We have no x-intercept. Our y-intercept is 0, 1. And we have that asymptote, that horizontal asymptote of y equal to 0. So we want to graph the log base 4. So again, we're just going to reverse these. So we're going to have 1, 0, 4, 1. I'd say 16 and 2. And remember, when it was negative 1, we would have 1/4, and we've got really small. All right, so we have 1, 0, 4, 1, and I know it's going to get really small and bend. I also know I have a vertical asymptote of x equal to 0. Remember, inverses, we interchange the x's and the y's. This is going to be none. We have to flip that, and we flip that. So the domain is from 0 to infinity, and this is all real numbers. So this is a real easy way to graph a logarithmic function. You can start out with the exponential function and reverse it, or my other suggestion would be to memorize, again, your basic shape. Vertical asymptote bends like this, and it goes through the x-axis at 1, 0.